Our next video in the atomic structure and nuclear decay unit is on the octet rule and ion formation. If we look at our learning standards and targets here, we're on the second standard of the unit. We need to be able to use the periodic table to predict relative properties of elements. And in this particular video, we're looking at the first two learning targets. We want to be able to explain the octet rule and apply it to ion formation and to predict the charges on monatomic ions. So the octet rule. The octet rule tells us the following. It says that atoms are most stable with a full outer energy level. So what that means then, if the first level is the outer level, it is full with 2 valence electrons. So if the first level is the outer level, 2 electrons make it full. If any other energy level is the outermost energy level, then it is full if it has 8 valence electrons. Now notice we're talking about if it's the outer level. Energy levels beyond the second level can hold more than 8 electrons, but if they're the outermost level, then it would be full with 8. So, which is why we call it the octet rule, the prefix octo referring to the number 8. As we will see starting in this video here, atoms will either gain, lose, or share their valence electrons in order to reach or to achieve that octet. Because as we know, most atoms do not have 8 valence electrons to start with. Most don't have the 8 valence electrons, so most of them are not the most stable they can possibly be. Just a few definitions before we dive into some examples here of forming some charges and some ions. Ions, or an ion, is simply a charged atom or group of atoms. A cation is a positively charged ion. An anion is a negatively charged ion. You'd think it might be called a dog ion if we call cations. Anions are negatively charged ions, and monatomic ions are ions that are composed of just one atom. Notice the prefix mono there, meaning one. And in this particular video and lesson, we will only be looking at monatomic ions. Again, ions composed of only a single atom. So looking at monatomic ion formation, we will start by looking at cations. Now, as we will see, metals will lose valence electrons to form cations. Okay, recall that metals are the elements that are on the left side of the periodic table. And we'll start by looking at group 1 ions. And as we will see, group 1 elements will always form ions that have a 1+ charge. And here's why. Let's take a look at lithium. If I look at a lithium atom, here's a model of a lithium atom where I have the nucleus here in the center, and know that there would be 3 protons there because lithium is atomic number 3. And then lithium has 3 electrons because, again, it's atomic number 3, so if it's neutral, it'll have 3 electrons, which we can see represented here. 2 in the first level and 1 in the second level. So it has 1 valence electron, as you would predict, because it is in group number 1. Now notice lithium's outer energy level is not full. Its outer energy level is the second level. It only has 1 valence electron. According to the octet rule, it would be more stable if it had a full outer energy level. Now, any atom essentially has 2 ways of forming an octet if it's going to form an ion, and that is it can either gain electrons to fill its octet or it can lose electrons to fall back so that the previous level is the outer energy level. So if lithium were to gain electrons, it would have to gain 7. Because it only has 1 valence electron here, so it would have to gain 7 in this second level to get the 8. The other option would be to simply lose 1 valence electron. If it lost this 1, now the outer energy level would be the first level. And recall, it is full if it has just those 2 electrons. So that's exactly what will happen here. The lithium atom will lose that 1 valence electron, and now notice it doesn't have any electrons in that second energy level. So the first level is the outermost level. Its outer energy level is now full. So to summarize what we've seen here, it loses 1 valence electron, which means we now have 3 protons and only 2 electrons, and those 2 electrons are in the first energy level. Now because we have 1 more proton than electron, that means we now have a charged atom. So notice we've gone from a neutral lithium atom, and we call neutral atoms, we call them atoms. And if an atom is charged, we no longer typically call it an atom, we call it an ion. So we've gone from a lithium atom where we just write the symbol Li, and now we have a lithium atom with a 1 plus charge. So I can either write it with a 1 plus as a superscript on the right side, or because it's 1, I can simply put plus. Okay, the 1 is understood to be there if there is no number there. And again, note we would call it a lithium ion. So let's look at another group 1 element and see if this same idea still applies. Let's take a look at sodium. So sodium has 11 protons. Even though we're not showing them, there'd be 11 protons here in the nucleus, and there's 11 electrons if it is a neutral sodium atom, because it is atomic number 11. Notice, just like lithium, it has the 1 valence electron. Now in this case it's in the 3rd energy level instead of the 2nd, but it's still just 1 valence electron. So like lithium, sodium could either gain 7 electrons into this outer energy level to make it an octet, or it could lose its 1 valence electron it has. If it loses that 1 valence electron, notice the outer energy level will now be the 2nd level, which has 8 electrons in it, meaning it's going to be a full outer energy level. So sodium has the 11 protons, 11 electrons, the 1 valence electron in the 3rd level. It will lose that outer electron. It will lose that valence electron. And notice now, we now just have the 2 energy levels, 2 electrons in the 1st level, 8 in the 2nd. Its outer energy level is full. So it loses the 1 electron. It now has 1 less electron than proton, which means we have gone from a sodium atom to a sodium ion. And again, notice how we write that formula, either Na 1 plus or simply Na plus, and that is the sodium ion. So all group 1 elements, and you can mark this on your periodic table, perhaps at the top of the group, all group 1 elements will form this 1 plus charge whenever they form an ion, because they will all lose that 1 valence electron. So let's take a look at group 2 now. And as you might guess, we will see here that group 2 elements will form ions with a 2 plus charge. So let's take a look at magnesium. So here's a picture of a magnesium atom you see here on the left. It has 12 electrons in total because it's atomic number 12, so 12 protons, 12 electrons. You'll notice it has 2 valence electrons, as we would expect because it's in group number 2. So the 12 protons and 12 electrons would make it neutral. But here's the thing though, is it will get rid of those 2 valence electrons. Just like sodium or lithium, it could gain electrons to get to its octet, but it would have to gain 6. Well, it's a lot easier to lose 2 than it is to gain 6. And if it loses the 2 electrons, you can see now we will have the 12 protons that we started with, and now only 10 electrons, 8 of which are in that 2nd energy level, which you can see here in this model. And that takes us from a magnesium atom, which is neutral, to a magnesium ion. And notice how we write that formula. It is Mg2+, because there are now 2 more protons and electrons. It would not be correct to simply write Mg+, or to simply say magnesium had a positive charge, although in general it does have a positive charge. The charge is 2+. It's not simply plus because there are 2 more protons than electrons. Alright, there are other metals that have 1 monatomic cation. We've seen that group 1 is always 1 plus. We have seen group 2 is always 2 plus. So magnesium, calcium, strontium, etc., they're all going to be 2 plus. There are 3 other metals that only form 1 monatomic cation, and those are as follows. Aluminum is always 3 plus, silver is always 1 plus, and zinc is always 2 plus. Please mark those on your periodic table and put the charges there. All other metals will form more than 1 cation. And here's what we mean by that. For example, copper could lose 1 valence electron and be 1 plus, but it could also lose a 2nd electron and be 2 plus. Another example would be iron, could be 2 plus or 3 plus. And here are just a couple more examples for you. Sorry, I didn't mean to click through there. You don't need to memorize those. It's just something I want you to be aware of at this point. So let's now take a look at anions, or negatively charged ions. So as we'll learn here, nonmetals gain valence electrons to form ions. Remember, nonmetals are on the right side of the periodic table. So let's take a look at halogens. And halogens are the group 17 elements. And as we will see, they will form ions with a 1 minus charge. So let's look at fluorine. So here's a picture of a fluorine atom. Fluorine has 9 protons in its nucleus. It's atomic number 9. And then notice there are 9 electrons in total, 7 of which are in that outermost second energy level. So fluorine, if it were to lose electrons, would have to lose all 7 of these valence electrons in order to get to its octet, or it could simply gain 1 to get to its octet. Gaining 1 is obviously much easier. So we start with 9 protons and 9 electrons, 7 of which are valence electrons. It then gains or receives 1 electron, and notice you can see it here now in the model. It now has a full outer energy level, meaning it's now the most stable it can be. So we've gone from 9 protons and 9 electrons to 9 protons and 10 electrons. So we now have 1 more electron than proton. So this will make the ion negatively charged. So notice how we write this formula. We still use F for the symbol. So we've gone from a fluorine atom. Now we have a fluoride ion. Notice the name. Anytime we have a monatomic anion, remember anions are the negatively charged ions, we change the ending of the element name to IDE. So we would not call this a fluorine ion. It is a fluoride ion. And then again, because it's 1 minus, we have 2 ways of writing it. We could just write F minus, or we could write F1 minus. They would mean the same thing. All right, so that would be for all group 17 elements. They'd all be 1 minus. Now let's take a look at group 16. As we'll see, these would all be 2 minus. You're probably seeing the pattern here. So let's take a look at oxygen. Now know that oxygen has 6 valence electrons because it's in group 16. There are 8 protons and 8 electrons there total, but the 6 valence electrons. So when oxygen forms an ion, it will gain 2 valence electrons to fill that outer energy level, and it will now have 2 additional electrons. It now has 2 more electrons than protons. So because it has 2 more electrons than protons, its charge is 2 minus. So we've gone from a neutral oxygen atom to an oxide. Again, notice the name. It's not an oxygen ion. We call it an oxide ion. And it has a charge of 2 minus. Alright, so that would be for all group 16 elements. Now we'll take a look at group 15. So group 15 nonmetals will form an ion with a 3 minus charge. And again, we'll take a look at an example. Let's take a look at nitrogen here. So here's a picture of a nitrogen atom. And this one, we actually see the protons and neutrons there in the nucleus. We know there'd be 7 protons because it's atomic number 7. And there are 7 electrons there because it starts as a neutral atom. So in order to fill its octet, nitrogen is going to gain 3 electrons in order to get that valence level, that second level, full with 8. And so if it gains 3 electrons, it will now have 3 more electrons than protons, making it have a charge of 3 minus. So we've gone from the nitrogen atom to the nitride ion, which is in 3 minus. And again, this would be for all group 15 nonmetals. All right, here's an example problem dealing with this stuff we've learned about so far. So for each element, determine the following. A, the number of valence electrons. B, if the element will gain or lose electrons in ion formation, and how many. C, the charge on its ion. D, the formula of the ion. And E, the name of the ion. So here are just a couple of examples with this. Let's think about phosphorus. So ask yourself, how many valence electrons does phosphorus have? You find it on the periodic table. You see it has 5 valence electrons. So will the element gain or lose electrons, and how many? Well, if it has 5 valence electrons, it can either lose all 5 to fill its octet, going back to the previous level, or it could gain 3. Well, it's easier to gain 3. So this element would likely gain 3 electrons. So if it gains 3 electrons, its charge would be 3 minus. The formula would be P3 minus, because the symbol for phosphorus is P, and the name of the ion would be the phosphide ion. Okay, so here are all those answers we just said. It has 5 valence electrons. It would gain 3. Its charge would be 3 minus. Notice we don't just say negative. Okay, the charge is 3 minus because it gained 3 electrons. The formula for the ion is P3 minus, and the name is the phosphide ion. All right, strontium. So strontium, we find it on the periodic table, is in group number 2. It would have 2 valence electrons, so it will lose 2 as opposed to gaining 6. Losing 2 is much easier, so its charge would be 2 plus. The formula is Sr2 plus, and then we would call it the strontium ion. Alright, so now I have some practice for you to do here. Same question as before. I give you an element, determine the number of valence electrons, and if it will gain or lose and how many, the charge, the formula, and the name. So pause the video when you see the element come up, try it yourself, and then play it and see if you got it right. Alright, the first one here is iodine. So iodine has 7 valence electrons. That means it will gain 1 electron when it forms an ion to get to its octet. That means it will have a charge of 1 minus. The formula would be I minus, so you could write I1 minus, and we would call that the iodide ion. Again, notice the IDE ending for the monatomic anion. Next we have sulfur. Sulfur has 6 valence electrons. Thus, it will gain 2 in order to get to its octet. Its charge would be 2 minus. The formula for the ion would be S2 minus, and we would call that the sulfide ion. The next one is rubidium. Rubidium, and I just realized this is a typo. Rubidium does not have 2 valence electrons. Rubidium has 1 valence electron. I need to change this. Rubidium just has 1 valence electron, so it would lose 1. And it would have a charge of 1 plus, and its formula would be just Rb plus or Rb1 plus, and we would still call it the rubidium ion. So in this video, we have explained the octet rule and applied it to ion formation, and we've also predicted the charges on monatomic ions. And you can see our next video there will predict the type of bond between 2 elements. And the following video will look at those periodic trends there of reactivity, electronegativity, and atomic size.